In this section, I will talk about the different data types in SQL. I'll also introduce you to tables, how we create tables, inserting data into our tables, and how to delete the tables we create. Before we go into the next section where we'll be creating tables and more databases, let's go through some SQL naming convention. When naming a table, it is important to use a descriptive name for your table. When people look at your table or the name of the table, they should be able to have a sense of what's contained within that table. Use snake case or camel case for naming multiple words columns. There will be times in which the name of your database or table or columns within your table might have multiple words. What you don't want to do is to have spaces between those words. The way to get around that is to either use the snake case, which is you have the first word followed by an underscore and then the second word. And if there are three words, all you need to do is just have an underscore to link all of those words. The other option will be to use the camel case. The first letter of the first word is capitalized, followed by small letters. The first letter of the second word is also capitalized, followed by small letters. Avoid using abbreviations, and if you have to use abbreviations in naming, you want to make sure that they are commonly understood. Names of tables, columns, database should begin with a letter. Avoid using long names and keep the length to a maximum of 30 characters. It is also suggested that you use uppercase for reserved keywords like create, select, where. You would have noticed that when I was typing earlier on and creating database, I chose to use capital letters in some instance and then small letters in other instances. We will be practicing this as we do more coding. A data type is an attribute that specifies the type of data that can be stored in an object. This could be integer, a character data, monetary data, or date and time data. In SQL, we have three main classifications of data types. We have the numeric data type, which stores information about integers or numbers. We have the string data type that stores information about characters. We have the date types that stores information about date and time. Under the numeric data type, we have the int, which stands for integer. We have the small int, we have tiny int, medium int, big int, decimal, and double. All the data type that has int in them stores integers or whole numbers. Decimal and double stores values that are decimals. Under the string types, we have CHAR, VARCHAR, and NVARCHAR. All of these stores character values, but can also accept numeric values. Under the date types, we have date that stores information about dates. We have datetime that stores date and time information. We have timestamp that stores current time and date. And we have the year that stores information about the year. Int is used to store whole numbers or integers. These are numbers that does not have fractions, and it has a range as indicated here. For us to use the int data type, we have to include the syntax. And the syntax is you write the column name, that's the name of the column, followed by the data type, which is int. The main difference between the int-related data type is with their range and storage. With big int, you're able to store way more compared to int, small int, or tiny int. But then you can see that you would require more storage units for big int compared to int and small int and tiny int being the list. In this program, we will be using int as that will be sufficient for all of the data we'll be working with. We also have decimal, which is under the numeric data types. It is suitable for storing current information or any data that includes decimals. The syntax for decimal is you have the column name followed by the data type decimal, and it takes on two arguments, the P, which is the precision, S, which is the scale. Now, precision is the maximum total numbers of decimal digits that will be stored both to the left and to the right of the decimal point. The scale is the number of decimal digits that will be stored to the right of the decimal. Later on in the course, we will work on decimals, at which point I would show you how the syntax works. The next numeric data type is double. Double has more precision and best used for storing larger numbers. And sometimes when we're not setting up the behavior of our decimal data, we can use double. Double has a precision of 15 decimal places. In this course, we won't be using double, we'll just be using decimal because that is sufficient for what we need to do. Moving on to our next data type, which is strings. As mentioned earlier on, strings are used to capture character data. And here we have some of the different strings data type. We have CHAR or CHAR. I'll just go with CHAR. We have VARCHAR. We have VARCHAR max, text, NCHAR, and NVARCHAR. The main differences, or one of the main differences between all of the strings data type has to do with the size of characters that you could have within each one, as well as the amount of storage needed. Now, I haven't said that with CHAR is a fixed width character string. What that means is that you can only store fixed character length within CHAR. Let's say, for instance, you'll be storing gender information in your database and you only want to capture female gender. So all of the gender within that database would be female. Another example I can think of is the US state abbreviation. The US state is abbreviated into two letters. So for instance, Arizona will be AZ, Texas would be TX. Now, if you collect an information about states in the US and you want it to be in abbreviation, because you know that that won't change, it's always going to be a two-character variable, then you could use CHAR as the data type within that field. VARCHAR is a variable with character string, which means that you don't have to have a fixed number of character within that field. It also has a maximum of 8,000 characters, 2 bytes in storage, 2 bytes plus the number of cars. In this course, we'll be using VARCHAR for our string data type because that will be sufficient for all what we'll be doing. We have the VARCHAR that allows you to store even more characters. We have text as well that allows you to store 2 GB of text data. We have NCHAR and the NVARCHAR. The main difference between CHAR and NCHAR is that with NCHAR, it allows you to store languages other than English characters. It's a fixed with Unicode string, which means you also have to have a fixed number of characters. But with NCHAR, if for instance you'll be working with characters in German, then you would need to use NCHAR because that allows you to store non-English language characters. And the NVARCHAR just means that similar to VARCHAR, it's a variable with Unicode string, and you can store up to 4,000 characters in that. So as mentioned, we'll be using VARCHAR in this course for string data types. And again, it does have a variable length character. It allows us to store between 1 and 8,000 characters. And importantly, variables are inserted in single quotes. So for instance, rainbow, cookies, John, all of these are character variables and has to be in a single quote. Now, VARCHAR is also capable of storing numbers, and this could be integers or decimal. The only rule is that they have to be in quote. So here we have 565, which is a number, but once it's inserted in quotes, then it becomes a string. The same way we have minus 90, which is a negative number, now becoming a string character because it's in single quotes. The syntax for VARCHAR is we have the column name followed by the data type, and then we have an argument n, which is the total number of characters we want that particular column to have. Now, earlier on we said that VARCHAR can have between 1 and 8,000 characters, but within the syntax, we have to specify the total number of characters we want that column to have. Now, I know this is a lot of information, but it all would make sense to you once we start creating our tables and working within the SQL server. Just to illustrate what the data type would look like in a table. So we have a table that contains some information about dog or dogs. The first column has the names of the different dogs. The second column has the different breeds. And then we have the ages of the dogs in the last column. The name column, because this contains strings or characters, would be a VARCHAR. The breed column also contains character information and will be VARCHAR. The age column represents the ages of our dogs, and these are all in integers, and would be int as a data type. It's also important to note that once we define each column, the data types within each column, you should only store variables within its appropriate or applicable data type. Now, why is this important? So for instance, in our dog table, we have the names of the dogs in the name column, the breeds, and in the age column, we have Wolfie as age 3, we have Coco as age 4, but instead of writing it in integer, we spelled it out in characters. And then we have Molly, the poodle, as age 5, we have Jacko as age 4, and we have Max as age 0, again spelled out. So what we're witnessing in the age column is that we have the whole number in integers. We have some of the ages in integers, and then we have Coco and Max in characters. Well, why do we want to avoid this? Assuming we want to present the ages of our dogs in human age, because as you may or may not know, the dog ages are quite different from human ages. And we are assuming that to convert the dog age to human age, we need to multiply the dog's age by 15. Well, we can easily do this with Woofy because we know Woofy's age is 3, and we just need to multiply it with 15, and we have 45. With Coco, well, within the system now, it's not represented as an integer, so how would the system do that calculation? There's going to be a problem here. With Molly, we can go ahead and do the calculation, just 5 multiplied by 15, we get 75. With Jacko, we could do the same thing, but then with Max, because the age, the dog age is in characters, then it's impossible for us to, I mean, because we can manually do the calculation, of course, but then if we were to compute this using a system, then it's simply impossible. So table 1 is not how we want to represent our data, but rather we want to be consistent as illustrated in table 2.